Hi friends, in this session we will discuss reading number 16, options and uncertainty measures, the Greeks. So this reading is considered as slightly difficult or very difficult by students who are trying to understand this reading by self. But I assure you, after watching this video, you will find this reading as very easy. This reading is easy, but the way content is presented in any book are presented in very complicated manner, and that makes things very difficult for students. So we will try to simplify this particular concept of Greeks, and we will discuss all the questions related to the examination, okay, which might show up in the examination. So when we begin the discussion, let's first consider what is the requirement of Greeks. Now consider two types of portfolio. Let's call the portfolio 1 as P1 and portfolio 2 is the portfolio P2. Portfolio 1 consists of long calls and long puts, and these long calls and long puts can be of anything, any strike price, any maturity, or you can imagine your portfolio, but this is the mainly long portfolio and long option portfolio, okay. And the second portfolio is the short call and short put portfolio, okay. Short call, short put, long call, long put. Now if you consider these two portfolios, for the portfolio 1, we don't need to manage any risk because this is primarily a long call, long put portfolio. And in long position in option, we know whatever the loss, the maximum loss is whatever we pay in the premium. So premium is the maximum loss for you, right? So we don't need to worry about this particular portfolio. No risk management is required here. No risk management is required because of the long nature, right? So for the long position holder, long option position holder, at the expiration, either he will get zero payoff or positive payoff. So there is only profit side left after you paid the premium. However, in case of the short call or the short put position, the earning is the premium collected upfront, but the short position holder might incur huge losses. As we know, for the short call option, the loss side for the short position holder is infinite. It is unlimited, right? So there is an unlimited payoff possibility, and payoff possibility, this means the unlimited payoff is profit for long and loss for short. Means short might incur huge losses here, and that's why risk management is required here. Now our discussion starts with three types of risk management, out of which two you already know, and the third one we need to discuss. So what are the risk management measures? Risk management means we want to protect ourselves from the losses, and ourselves meaning we will assume, you and me, we both will assume that we hold these type of portfolios or this type of portfolio P2, which has the net short position, okay. So short call or short put, you can imagine anything, okay. Now what are the possibilities or what are the measures available? So first is the covered position. This is the first type of risk management measure for short portfolios or short option portfolios. Second is stop loss, and third is Greeks. First two are simple measures, simple risk management measures or hedging measures, and this Greeks is considered as a sophisticated measure. Sophisticated measure to manage the risk of short option portfolio. Now here, first let's discuss what is a covered position. To understand the covered position, we can use very simple example. Assume your position is short call position, okay. So this is existing position. Now we want to protect ourselves from losses, and we know if we hold the short call position, if the underlying price moves up, then we will incur losses, assuming the option is exercised. If it moves upwards, then we will incur losses, right? So we want some position to hedge this particular portfolio. We want some kind of position which generates profit at the same time. What we can do here, we can use long underlying, okay. So we'll take position in stocks. which compensates for the losses generated from this short call in case the underlying price moves up. Remember, as the underlying price moves up, because you already hold these stocks, it will generate profit for you, and at the same time it will also generate losses for you. Like this short call position will generate losses for you, and losses and profits will get compensated. And that's how the covered position can be hedged. Covered position can be used for hedging of short call portfolio. Then let's discuss the short put portfolio or the short put position. In this case, we know short put generate losses when the underlying price declines, okay, or move downwards. So we need some position in underlying in this particular case where it generates profits when underlying price moves down. And what is the position? Short position in underlying, right? And here I'm assuming like you are comfortable with the concepts like the what happens in when you hold the long stocks or the short stock, when you do the short stock or long stock. Okay, so you purchase stock or you short sell stocks, right? So if you take the short position in stock, we know unlike long position in stocks, if you have the short position in stocks, when underlying price moves downwards, you will generate profit, but if the underlying price moves upward, you will generate losses. For short put, you will generate losses in case the underlying price moves downwards. At the same time, because you already hold the short position in stocks, you will generate profit from this position, right? And it will compensate for your losses generated from the short put. And that's how you can manage the risk in this case, the short put case. This particular setup is known as the covered position. Okay. There is one more discussion like do nothing strategy. Do nothing strategy means you take the position in options and do nothing. Okay. So leave it like that. Whatever happens, happens. So that's not the actually hedging strategy or risk management strategy. It is just the basic strategy like you're doing nothing. Okay. So opposite of doing nothing is the covered position. Okay. So this is the first strategy. Now next, second strategy which we can use for hedging our portfolio is taking stop loss. Or using stop loss, right? So in stop loss case, your position will be squared off, assuming like say you have short call position, and if things go south, right? If it goes in the negative direction, then your position will be squared off. You are now like, I assume like you are already comfortable with the short loss strategy, stop loss strategy, because we already discussed the stop loss segment or the topic in book number 3, right? So we will use stop loss, and if the stop loss or if the loss exceeds certain limit, your position will be squared off, and system will automatically take the long call position in this same option, and this position will be squared off, and you won't generate further losses. Okay. And similarly for short put, we will take long put position in stop loss case, and same thing will happen here. So that's a stop loss strategy. Okay. So again, this particular strategy is not very foolproof because you will generate some losses because stop loss is not going to work immediately. You will put stop loss after certain limit, and that creates a problem because you have to bear some losses, and after those losses are like borne by you, then you will have like squared off position, and after that you won't have any further losses. Still, this is a risk management strategy, but not a very foolproof strategy. Okay. The third strategy or the third very sophisticated measure of risk management for the short option portfolio is Greeks. I'm assuming like I'm using this word sophisticated or very complex strategy. So the reason is, in the Greeks, when you use the Greek measures for option hedging, okay, option portfolio hedging, we use certain positions which hedges or which compensates for individual factors. Now let's discuss one thing first. In BSM portfolio, in BSM option pricing model, we discussed option pricing for call and put, and we will just use the formula for call. What is the formula for call in option pricing's case? So S0 multiplied by ND1 minus x into e to the power minus RT multiplied by ND2. So this is the formula. This is basic formula. We can ignore put for now because put formula is just the opposite of call formula. For D1, we use formula ln of S upon X plus R plus sigma square divided by 2 or multiplied by 0.5, whatever is your preference, multiplied by T divided by sigma root T. And D2 is D1 minus sigma root T. So this is a formula for call option pricing using the BSM model. This means the call options price is impacted or affected by these factors. First is the S0 underlying price, U price. Second is the X strike price. Third is rate, risk-free rate. Fourth is sigma, which is your volatility. And fifth is time period. So these are the factors 1, 2, 3, 4, 5. So these are the factors which decides the fate of the option, which decides the price of the option. So if you are the short option position holder, all these factors will impact your position, right? Because these are used in the formula, and we know from the properties of option chapter like how these particular factors affect the option prices, right? So we know, like for example, underlying price affects call option positively and put option negatively. Means if the underlying price increases, call option price will increase. If the underlying price decreases, put option price will increase. If the underlying price decreases, put option price will decrease. And if underlying price increases, put option price will decrease, like this, right? Now we know there is some kind of relationship of this S0, strike price, risk-free rate, standard deviation or volatility, and time period T. Now if we consider these factors, this one particular factor does not change throughout the life of the option. If you consider, say, a call option which has a strike price of say $150 and the maturity, time to maturity is say 6 months, underlying maybe ABC stock or okay. So the particular factor, this particular factor will not change because strike price is fixed and constant throughout the life of the option. So this is not going to change. That's why we don't need to worry about the X factor, that is a strike price factor, right? However, as the option reaches to maturity, volatility might change, which will impact option prices. Time period will automatically keep reducing because option is reaching to maturity. So time period will affect the option prices because it is also included in your BSM formula. Then volatility, yeah, risk-free rate. Risk-free rate might keep changing and we have to use a new risk-free rate in our model, which will again impact the option prices, and underlying price keeps changing, which affects your option prices, right? So all the remaining factors, S0, R, sigma, and T affects option price. And that's why we need to manage these factors or use certain positions which helps us in compensating losses generated because of these factors, right? So here again, what do we have now? We have S0, we have S0, we have time period, we have volatility, and then risk-free rate, okay? And what are we measuring here? We are measuring sensitivity. We are measuring sensitivity of these factors, the S0, T, sigma, and R, with respect to option, call or put option. Here throughout the discussion, I will use call option primarily, and whenever it is required, I will also discuss the put option, but mainly our discussion will focus on, or for the illustration purpose, or for the explanation purpose, I will use the call, because if I keep jumping between call and put option, this will create confusion for you. Just remember what happens in the call and automatically you will be able to understand what happens for the put. Wherever it is required, wherever there is a specific discussion of put, I will give you a specific explanation, right? So you don't have to worry about it. Now here, these sensitivity measures are given a certain Greek letters. For example, sensitivity of underlying price to option. Remember, delta is the sensitivity of sensitivity of underlying to option. Okay, and we call this as a delta. You can denote delta as like capital delta or small delta like this. There is one more measure related to delta only, which is known as the gamma. Okay, so we will discuss everything in detail. So right now, don't bother about it. So delta and gamma, these relates to underlying price. Then we have measure theta, and theta measures the time sensitivity with respect to option. Then we have volatility measure, okay, volatility sensitivity measure, which is known as kappa, but in books, this is written as vega. So you will use this word, or you will see this word vega in your curriculum, in books, even in the Falcons notes. So or even if you use any curriculum or any other author's books, it will mention vega only. But there is no such letter in Greeks like the vega. Okay. Greek letters, we already know what are the Greek letters: alpha, beta, gamma, delta, vega, kappa, not vega. By mistake I said vega. Okay, so alpha, beta, gamma, kappa, rho, mu, sigma, like this. So these are the Greek letters, and there is no such letter as vega. However, this vega is used by like in this finance industry. Okay, so this is commonly used now instead of kappa. So the original word given or original letter given for measurement of volatility sigma was kappa and not the vega. Some authors still prefers using kappa instead of vega. And in exam, if you get question on kappa, you have to remember that the question is about vega. In this discussion also, I will use vega only. I'm not going to use kappa again and again. But this information is provided to you just to know, like in case Garp asks you question on kappa, maybe Garp things like just check what if like what students do if they see kappa. Okay, so this is assumed that students should know all these things. What if Garp asks you question like this? So you should not lose lose your points just because you don't know what is the meaning of kappa. So kappa is vega. And the last one is the sensitivity of risk-free rate to option, which is known as rho. Okay, theta, kappa, rho, delta and gamma. So here, these are the measures. Delta, this is the delta. It measures the impact of stock price changes on the option. Gamma is like this. Okay, just read it. I will give you explanation afterwards. Theta, vega and rho. Vega is also mentioned as kappa here. This is the K. Okay, K is for the kappa. Fine, and this is the explanation which I just mentioned, like the kappa is vega only. Okay, now this is the discussion relates to the covered position, stop loss strategy and Greek letters. So we discussed these two, covered position and stop loss strategy, and now our discussion starts with the Greek letters. So first we will discuss the first Greek letter and the most important Greek letter, and there are high chances that you will see question on this Greek letter, which is a delta. And I will primarily use delta to explain all the concepts related to the Greeks. Okay. Now understand, before we begin the discussion of delta, there is something called delta first. Then there is something called position delta. Then there is something called portfolio delta. We will discuss each and everything one by one. We'll start with a very basic discussion. Just imagine a scenario. Illustration 1. Okay. And I might take some extra pauses here because these illustrations are not written in front of me. So I have to give these illustrations to you impromptu. So we'll start with the first illustration. Assume underlying price currently is trading at $100, and we don't have to worry about in this discussion when we are discussing delta. Remember, we are splitting all the factors separately. So we don't have to bother about other factor when we are discussing one factor. So like right now we are discussing delta. So we don't have to worry about the time, volatility, risk-free rate or any other thing. So we will stick only to delta discussion. Okay. So currently S0, currently this underlying is trading at $100 and the call option is trading on the same underlying at $10. You can imagine any strike price, any risk-free rate, any volatility. We are not bothered about it. Now, when the underlying price increases to 110, okay, so underlying price increased to 110, call price increased to 15. This is what happened. Okay, just imagine this happened. And when underlying price decreased to $90, call price decreased to $5. Okay, so this is fine, right? So we know for call option, when the underlying price increases, call option's price increases, correct? When the underlying price decreases, call option price decreases, correct? Right? Now what is delta? Delta is change in call option price, the ratio of change in call option price with respect to the change in underlying price. That is S, we will just call this as S new. Let's call this as instead of S0, let's call this as SN, just to indicate the new underlying price. Okay. Or we can do this like there is alternate measure or method. Change in call price divided by change in underlying price. This is how you measure delta. Okay, this is the proportion, okay, ratio. So what is the change in first case? This is the first case, and then this is your second case. Okay, for the first case, price increased to 15 from 10 when underlying price increased to 110 from 100, which gives us the delta of 0.5. Okay, you can do the calculation. It is 5 divided by 10, which is 0.5. For the case 2, this is again the formula is same. Price decreased of call option, price decreased from 10 to 5 when underlying price decreased to 90 from 100. And even in this case, we will get delta of 0.5. Why? See here, if you solve this, the numerator term, you will get the answer -5. And if you solve denominator, you will get the answer -10. So -5 divided by -10 is plus 0.5, not minus. Remember, plus 0.5, right? In both the cases. So this is how you measure delta, right? So it is simply the change in underlying price with change in option price with respect to underlying price. We can also see what happens in case of put option. If we consider put, and let's assume the same scenario. Put is currently trading at 10 when underlying price is 100. And again, you can take any strike price, time to maturity or any risk-free rate. It doesn't matter for us. When underlying price increased to 110, our put option price decreased to $5. And when underlying price decreased to 90, our put option price increased to 15. Okay. And now we will solve or calculate delta for put option. Delta of put option. So in first case, it is price decreased to 5 when underlying price increased to 110. And the answer is -0.5. In second case, price increased to 15 from 10 when underlying price decreased to 90 from 10. Like very proper, we know put options price will increase when underlying price decreases, put options price will decrease when underlying price increases. Again, in this case, you will get -0.5. Okay, so don't bother about these -0.5, like 0.5, same figures. If you use some different values, your figures will change, but one thing will not change. That is the sign, this negative sign. Okay. Now again, we will recall our properties of option discussion, where we discussed underlying price is positively related to call price and negatively related to put price. Means when the underlying price increases, call price will increase. Underlying price decreases, call price will decrease. When underlying price increases, put price will decrease. When underlying price decreases, put price will increase. So put price is inversely related to underlying price. Okay. And this is what is shown by this delta. If you just consider the put option shows like the change is negative. Okay. Whatever is the magnitude or whatever is the quantity, change is negative. In this case, for the call option, the change is positive because underlying price and the put call price are positively related. Fine. Now here. Now, what is mean by delta of call equal to 0.5? Okay. This means when underlying price changes by 1%, call price will change, or put price also, because we use 0.5 everywhere, will change by 1% multiplied by delta, which is 0.5%. Okay. So if the underlying price changes by 1%, your call price will change by 0.5%. And we can prove this using, assume currently underlying price is trading at 100 and it increased to 110. So, and currently say like call option price is trading at $10. So what will be the new price of, or what will be the change in price for this call option? We know the delta is positive and here the total change will be 0.5, that is 5. Okay. Original price plus change, this is change. Okay. Change is by 0.5. So the final price of the call which you will get is 10 plus change because of the delta, because of this increase from 100 to 110, and you will get the answer 15. Right? Very easy. Because it's the positive change, we have to give the positive impact. In case of put option, currently put option is trading at 10. So the change will be minus 0.5 multiplied by 10 because underlying price increased by 10. And if you adjust this, so you will get answer 10 minus 5, which will give you 5. Okay. And you can reconcile this with this. Okay. Just see here. Just see this. Okay. We can clearly see this difference. And similarly, you can do it for 90 or like that. Consider that as your homework and just try it. Now, this is what we call as delta. Okay. So whatever is the discussion, like this is delta, delta. This is delta. This is delta. Okay. So this is delta. Finish. Now we got one rule here. Delta of call is always positive and delta of put is always negative. Got it? Delta of call is always positive, delta of put is always negative. Fine. Now remember, if you take long position in delta, if you take long position in delta, any delta, delta of call or delta of put, you will hold exactly that position. Meaning, assume like this particular call option has a delta of say 0.75 and put option has a delta of 0.25. Okay. If you simply take position, long position in this call option, in just one call option, So you will have positive delta of 0.75 because that calls delta is plus 0.75, right? So plus 0.075, and you are longing it, you are taking it. So you will automatically get plus 0.75 delta. On the other hand, if you take long position in put option, that put option has a negative 0.25 delta. If you take the long position in that, so you are taking that negative weight, negative delta in your portfolio or in your position. So you will have delta equal to minus 0.25. Okay. So this is for the long. And just like the payoff is positive for long. So opposite is true for short option holder. So in similar fashion, for short position holder, he will get the negative effect of whatever delta is applicable for the positive. So say calls delta is plus 0.75. If you short it, you will have negative of that delta. So for this call, which has a positive delta, which always has a positive delta of 0.75, if you take short position in this one call, then you will have negative 0.75 delta in your position. And if you take short position in put has a negative delta. If you take the short position in that, so negative delta will become positive for you. So you will have the impact of positive. Okay. Now alternate explanation of what is meant by this positive delta and negative delta. Okay. Now again, if you see, like I'm repeating some things again and again, so I'm not repeating it because this discussion is like this, I have to repeat it. Now understand, when underlying price increases, call price will increase. If you hold the long call portfolio, your portfolio will increase, right? Your position will increase, your position's value will increase, which is depicted by positive sign. If you take the long position in put option, if underlying price increases, your position will decrease. This is what is indicated by this negative sign. Okay, so negative. If you take short position in call, if the underlying price increases, you will generate losses, your portfolios or your positions value will decrease. This is indicated by negative sign. Okay. And if you take opposite position, the short position in put option, then as the underlying price increases, your position will increase, your position's value will increase. That's why this is indicated by positive sign. This is very simple. And this particular thing is known as position delta. Okay. Now, delta, always positive for call, always negative for put, always positive for call, always negative for put. But depending on position you take, long or short, its sign will change. If you have call, which is a positive delta, if you take short position in that call, you will have the negative delta. Why is this happening? Because you are taking position in that. If you have long position in put, you have negative delta. But if you take short position in put, you will have positive delta, which is again happening because of the position you take. And that's why this delta is known as the position delta. So position delta is nothing, like it is not different from delta. It is just the indicative of delta in your position, in your long position or your short position. Please remember this. Okay. Now again, extending this position delta discussion, assume there is one call option which has the delta of call option equal to say plus 0.30, and you take long position in 100 such calls. You take long position in 100 such calls. So your position delta is equal to plus 30. So 0.30. So 0.30 delta contributed by every option, and you have 100 such options. So your total position delta is plus 30. This plus 30 of delta indicates when underlying price increases, when underlying price increases by $1, when underlying price increases by $1, your total positions value will increase by $30. Okay. when underlying price increases by $1, your total positions value will increase by $30. On the other hand, if you take short position, in short is indicated by minus, right? So short position, 100 short positions or 100, you take 100 short positions in this call and delta is 0.30. This will give you delta equal to minus 30. You will always write delta like this. Don't write dollar or something like in front of delta. This means when underlying price increases by $1, your position value will decrease by $30. If the underlying price decreases by $1, your position value will increase. It is negatively related. It will increase by $30. Fine. And similarly, you can do for put. Use it as your homework, or you can do it as your homework. Okay. And let's take, it is 0.45 negative multiplied by, you take 500 positions, and this is obviously long because there is no sign, multiplied by negative positions in this, which is obviously short, and simply calculate your deltas. Okay. Now remember, there is one really good thing. Once you get all these position deltas, okay, so you have these positions, position delta of this, position delta of this, position delta of this, position delta of this. Once you have position delta, you don't need to bother about the remaining side of the option. Okay, so just one example for this, like what is the meaning of what I'm saying. So imagine there is one particular portfolio 1. This portfolio is structured in certain manner where delta of, or position delta of this portfolio is plus 300. And then there is one particular portfolio number 2, where the delta of this portfolio is plus 300. Both the portfolios consist of different call options, different like strike prices, maturities, different compositions, but the delta is plus 300 and plus 300. Now, we don't have to worry about what's inside the portfolio. As long as we know like the portfolio has a delta of plus 300. If we were to hedge this particular portfolio, P1 or P2, we will use exactly same measures for hedging. Okay, so we don't need to change our hedging measures because now we are only concerned about this delta. And what are we hedging here when we consider, or when we say like plus 300 of delta? What are we talking about? We are just hedging. When we hedge this delta, we are just hedging the impact of underlying price on option. We are just eliminating that particular impact. We are just hedging that particular impact, and we are not bothered about the remaining impact. Maybe the option is impacted by gamma, option is impacted by risk-free rate, option is impacted by other factors. But we don't have to worry about other factors when we are just planning or when we are hedging using this particular, like only delta. Okay, so when you are hedging delta, we don't bother about volatility, risk-free rate, and theta. That is a time factor. Okay. Now this is the discussion of position delta. Okay. You have to do these calculations and just calculate the position delta for yourself. Now we'll discuss portfolio delta. Okay, so just for the explanation purpose, portfolio delta is simply summation of position delta in that portfolio. Okay, so just imagine there is one portfolio P1 where this is your position 1, 2 and 3. The position 1 is, say, just imagine like it is a call option, long call option, which brings the position delta of 200. Second position is long put option, which brings, say, delta of minus 100. Obviously it will bring the negative delta. And next is third position is the short call. There are different calls, okay, different call, different puts, which brings the negative, remember, because this particular, like we are using the short call, it will bring the negative position delta. Okay, and let's assume this is 250. Okay, so simply the portfolio delta is equal to summation of this, plus 200 minus 100 minus plus 100 and then 250. So the answer is 150, minus 150. Got it? Very simple. You can also consider portfolio 2. I'm just writing random values, and this is homework for you, and calculate portfolio delta for this. Fine. So I'll just revise everything for you. Okay. So first, delta. Delta impacts or delta measures the impact of underlying price changes with respect to call option or the put option. Now here, how do we measure these impacts? So change in call price divided by change in underlying price. This is not the actual way to measure the delta. This is for the explanation purpose. The actual way to measure the delta is different, which I will explain on the later part. Right now, just focus on this part. So this is how we measure it. Delta is measured like this. So for call option, the delta is always positive. For put option, delta is always negative, because these deltas are indicative of the relationship of underlying price impact on the call price. So if the call price increases, if the underlying price increases, call price will increase, underlying price decreases, call price will decrease. This is a positive relationship. That's why call delta is positive. If the underlying price increases, put option price will decrease. If the underlying price decreases, put option price will increase. This is the indicative of negative relationship. That's why puts delta is negative. Now, if you take the long position in these options, you will own those signs. Remember, if you take the long position in these options, you will own those signs, and that will be your position delta. If you take short position in these options, you will hold negative sign of original delta. So if for the call option, the delta is positive, if you take the short position in call option, you will have the negative delta. Put delta is negative. If you take the short position input, you will have the positive delta. This is the position delta. If you take position in multiple options, still you will own the negative sign or positive sign depending on long option or the put option. Long option or the short option. But you will have that much quantity now. Just like we discussed, say the calls delta is 0.3 and you take 100 position in that particular call. So your position delta is that, right? Position delta is 30. Which indicates the impact of $1 increase in underlying versus $1 increase or $1 decrease in underlying on your position. Remember, on your position. As soon as we enter into positions, we forget or we don't bother about what's in the call. We don't have to worry about it. We just focus on the positions, right? Next, when we discuss the portfolio delta, we simply sum all the positions delta. Okay, simply take the sum of all the position delta, and you will get the portfolio delta. And once you get the portfolio delta, we have to take positions in some other instruments, in some other securities, which gives us the equal amount of negative sign delta. Negative sign, I will explain what is the meaning of this. For now, just know this. Negative sign delta or opposite sign delta, instead of negative, opposite is correct word. Opposite sign delta, which compensates for the delta and makes our portfolio delta neutral. So what is this portfolio? What is this delta neutral portfolio? Delta neutral portfolio. So delta neutral portfolio is the portfolio whose delta is equal to 0. This is portfolio delta equal to 0. Remember, actual delta need not be 0. We are concerned with the portfolio delta. I will give you an example. Say this is portfolio 1 and position 1, 2. Position 1 is minus 500 delta and position 2 is minus 200 delta. So total portfolio delta is minus 700. Got it? Now, minus 700 is your portfolio delta after summing up all the positions. I will take position in some securities. In some securities, it can be anything. Okay, we will discuss what type of securities we can use. I will take position in some securities which will bring the delta of plus 700 in this portfolio. Okay, this is after taking position, after taking new position. And if you take the total of, remember, this is the portfolio delta, right? And this is new brought delta, and total is 0. As soon as your total portfolio delta is 0, we call this as delta neutral portfolio. Clear? Delta neutral portfolio, which has a delta of 0. Okay, I hope this is clear. Now, what type of positions we need to take or we can take in to hedge this portfolio? Okay, so to make the delta neutral portfolio, we can use two types of positions or two types of securities. First is the options and second is the stocks. Fine. So first is the options, second is the stocks. Stocks are preferred. Options, if Garp asks you to use the option, we have to use the option. Okay. Now let's discuss this one by one. And please remember, as I said, once you get the portfolio delta, we don't bother about what's inside that particular portfolio. So here also, I will directly mention the portfolio delta and I will show you how we can hedge this particular portfolio delta and make the portfolio delta neutral. Okay. Let's start with this. Let's assume there are three portfolios. Portfolio number 1. This has the negative delta of 1000. There is portfolio number 2 which has a negative delta of 250, and then there is a portfolio 3 which has a negative delta of 750. This one will be homework for you. I'm providing this in advance or specifying this in advance. I will just explain these two, and please remember, if you solve these two, you will be good with rest of the section which relates to the delta hedging. Okay. Now first let's discuss the option, using option for making portfolio delta neutral. Now assume you have one call option and then one put option. Call option has a positive delta of obviously 0.5 and put option has a delta of negative minus 3.5. Okay, so these are the options available. Now what options, like what's like strike price, maturity and all, doesn't matter for us, because we have to just make sure we are bringing that much delta in our portfolio. Obviously the underlying should be same. Okay, so underlying should be of some relation. You can't bring some like outside delta in this portfolio. You have to make sure that the underlyings are relatable and there is parity in these deltas. But from the exam perspective, you don't have to worry about it. This will be assumed, okay, that the underlying is relatable. Now, call option and put option. Now, how can we use call option and put option to bring negative or the opposite sign delta here? Okay, so for the hedging purpose. Just remember these two values. Yeah, just remember these two values. Okay, so okay. Now first we will use call option. What is our goal? Our goal in the portfolio 1, we want to bring plus 1000 delta from this call or this put. If we decide to go with the call, then we have to take the position in (1000) divided by 0.25. See, those who are good with mathematics, you will understand why I divided. Those who are not good with the mathematics, just remember we have to divide it. That's a very simple thing. Okay, so don't expect from me to explain like why are we dividing it and like that. That will just unnecessarily stretch our discussion. And trust me, converting this Greeks class into mathematics class will be very problematic for our discussion, because those who are good with the mathematics, they don't like it, and those who are not good with that good with the mathematics, like the intuitive mathematics, they won't understand it. Okay, so for now, just remember we have to take the position in this manner. Okay, so we will take position in 4000 calls. And what will be the position, long or short? You have to take this decision in exam. Should you take the long position or the call position? What is our aim? We want to bring the positive delta with the help of call. We know call has a already positive delta. So simply take the long position in these 4000 call options. Okay. So 4,000 call options. 4,000 call options long, and which will bring plus 1,000 delta. I will reconcile this for you. You took the long position in 4,000 call options, which has a delta of 0.25, which gives us plus 1,000 as answer. So 1,000 delta introduced in your portfolio. If you take the sum total of this, automatically you will get 0. Okay, existing position, new position, existing position, new position, new delta, and automatically your portfolio is now delta neutral. This portfolio will not be affected by underlying price small changes. Small changes in underlying price. Remember, delta is only the measure of small price changes, small changes in price. It is not applicable if the price changes are large. So this is what you need to remember. Small changes in price. Underlying small changes in price. I will repeat this again and again and again so it fits in your mind. Okay. Now this is the first thing. What if we want to go with the put option? So for put option, same formula. Existing delta, position delta divided by 0.35, because this is a delta of your put option. 1,000 divided by 0.35. This will give us answer, which is minus 2857. Okay. So for now, don't bother about it. I will explain you what we need to do here. So we need to take the position in 2,857 put options, but we know taking long position input will bring negative delta in our portfolio. We already have negative delta. Negative will be further negative and it will increase our delta of portfolio. That's why we need to take the short position in portfolio. Short position input. So take the short position input. So take short put, which will bring plus 1,000, and again it will make the portfolio delta neutral. Now reconciliation, you took 2,857 short put, okay, multiplied by 0.35, simply multiply it, 2,857 multiplied by 0.35, which will give you 999.95 positive delta. Okay. So in exam, you're not going to face the problem with this particular part. The part is like calculating delta. Majorly students face the problem in deciding should they take the long position or the call position. That's why I conducted or discussed like that long or short position discussion that extensively. Your decision should be like this. First, calculate total number of options. Okay, total number of options you need to use for making delta neutral portfolio. Now, once you get this, simply imagine what is the natural position delta, natural delta of a call or put, and now decide what type of delta you need to bring in your portfolio, and based on that take the decision. Okay, so if it is a call, you want to bring the positive delta, simply pull the positive delta. If it's put, natural delta is negative and you want to bring the positive delta, take the short position in that. Very simple, very straightforward. And for the next 250, this is also homework for you. Okay, so 0.25 to decide call, total number of calls, and for puts 250, 0.35 total number of puts, and this is how you can decide total number of calls and total number of puts. Number of calls, number of puts, and you will get your answer. Very simple. Got it? This is how you can do it with the help of options. Now we will see how to hedge our portfolio or make the portfolio delta neutral with the help of stocks. Now, what if theoretically, if I decide to calculate the delta of stock itself, delta of stock, that is sensitivity of underlying price with underlying price. Sensitivity of underlying with underlying means if the underlying price increases from 100 to 110, so in numerator, change in stock, in denominator, change in stock. which will give us the answer of 1. This gives us a result of delta of stock with itself is always equal to 1. Now, one important note, this is my trick to solve these questions in exam or in interviews. If you are planning to appear for interview, show for the interview, don't use this type of language. They won't understand this, because this is my own trick to simplify this discussion. That assume the delta of stock is equal to 1. And now if you have portfolio which has a negative delta of 1000 and second portfolio has a negative delta of 250, how many positions in stock you need to take to bring the opposite delta? Simply, we know stock has a positive +1 delta. If you take the long position in stocks, it will bring positive delta, right? So here, because we already know the stock has a positive delta of 1, we have to simply take position in 1000 stocks, which will bring positive 1000 delta with itself, and it will make the portfolio delta neutral for this 250 stocks, and it will make portfolio delta neutral like this. Very simple and straightforward. Okay. Now the reconciliation. Okay. So I guess I love reconciliation part, because I worked as an auditor for 7 years and there was a lot of reconciliation there. Okay. And reconciliation helps in your understanding. Okay. So it will help you in getting what actually happened here. So the portfolio 1, in case of the portfolio 1, this has a total delta of -1000, meaning if we consider this stock, and remember, you can't bring any random stock. This stock is actually underlying stock. Okay. Okay. Now see, if this underlying stock's price increases by $1, if the underlying price increases by $1, as we discussed, your portfolio, this -1000 is indicative of, for increase of $1, your portfolio will suffer by -1000. This will be your total loss. Your loss will be $1000. Very simple, easy to understand, right? Now, if you hold, this is your existing position. New position is 1000 stocks long, right? Now, if you take 1000 long position in these stocks, 1000 in total, and this stock price increases by $1. So automatically, because you hold 1000 such stocks, so total gain in this case will be $1000, right? So this is your new position. This is your old position. Loss 1000. Why this is happening? This happened. Stock price increased by $1. Stock price increased by $1. Your stock position resulted into +1000 profit, and your portfolio position resulted into loss of 1000. Loss of 1000, gain of 1000, 0. This gives us delta neutral portfolio. Means this portfolio is unaffected by stock price increase. You can do this in the reverse order. You can consider the decline in $1, decline of $1 in stock price. Okay, so decline of $1 in stock price. If there is decline in decline of $1 in stock price, then what happens? This particular long 1000 portfolio will generate loss of $1000. At the same time, this will result into gain. Remember, the impact will be reverse. If the stock price increases, this position delta, if your portfolio delta is negative, it will result into this will result into losses. If the stock price decreases, it will result into gains because of the negative sign. For this loss, there will be gain of $1000. Loss and gain. Again, 0. Got it? Very simple, straightforward, right? So this gives us the proper delta neutral portfolio which is not sensitive to underlying price changes, but only when changes are small. Okay, when the changes are small. Now here the problem is, I hope you understood what is a delta neutral portfolio. And for I would recommend you to read like notes, these notes. Okay, so just read these notes, and everything is mentioned here. Whatever you need for your understanding, everything is mentioned in so crystal clear form that you don't have to bother about it. Okay, all the illustrations are provided for your revision and all like that. Okay, so here we have one more discussion. So this discussion is the range of the delta of call is 0 to 1. Okay, and range of delta of put is -1 to 0, because we know it is naturally negative. Okay, put delta is naturally negative, call delta is naturally positive. So it will, like, when the option is not sensitive to like underlying price changes, then it will show no changes, and it will keep increasing as we move into the deep in the money. And the put option price will move in the negative direction. Always remember, as the put option goes deeper into the money, the put delta will decline because of the negative sign. Okay, so that because of negative sign this happens. Now here, this is the range of call delta 0 to 1. This is your strike price, kind of in between, and this is 0 to -1. Got it? Very simple, very straightforward. So what is the meaning of this? Imagine a scenario, like I'm explaining you right now, like what is mean by zero delta, what is mean by delta of 1, what is mean by negative delta, what is mean by zero delta for put option. Now imagine a scenario, you have one particular option. Okay, so you took the position in one, you have long call option, and the strike price is 100, and currently underlying price is trading at $20. Time to maturity is say 1 day. Okay, now imagine a scenario that this particular underlying price increases by $20. Okay, from $20 to $40. This happened. Do you think there will be some change in call price? Just imagine, think. If you say yes, you're totally wrong. If you say no, you're correct. Why? Because just 1 day is left for the maturity, and currently the underlying is trading at $20. It is not at all possible that this option will get exercised. By no scenario. There is no possible scenario that this option will get exercised. And because this option is not going to get exercised, the option prices will not fluctuate because of the fluctuation in underlying price. These prices will be very dead like. Okay, so this tells us the delta is 0. Delta 0 means underlying price is changing, but option price is not changing. When this happens when there is certainty of the option will not get exercised, meaning option is deep out of the money. Okay, so when the option is deep out of the money, this is applicable for put option, this is applicable for the call option. Now when option goes to, like, when this is 1, amazing, like imagine the same scenario, but now imagine underlying price is trading at $200. If the underlying price increases by $10, your option price will increase by $10, because the option holder knows, whoever is buying that option knows that now he will get extra $10 because of this increase. If the option price decreases by 10, then the option price, if the underlying price decreases by 10, the option price will decrease by 10, because now the holder knows that he is not going to get that extra 10 payoff, right? So payoff is so related to this particular option, and there is so certainty about this, like getting this payoff, the option will show delta of 1. This will be in equal movement. Like if the underlying price increases by $1, option price will increase by $1. If the underlying price decreases by $1, option price will decrease by $1. This happens in case of call. In case of put, the opposite will be true. So when the option is deep in the money, In that scenario, when deep in the money is there and there is 100% certainty of option will get exercised, option will show delta of 1. Same is applicable for put. When option, the put option is deep in the money, again deep in the money for the put option will be in negative direction. So delta of put will be -1. It will show exactly opposite impact on the option compared to underlying price movements. Okay, underlying price movements. Okay, so that's all the discussion of delta. In the next part, we will discuss gamma, vega, kappa, and the remaining discussion. So this was the main discussion. After this, our discussion will be faster because now you know all the positions and everything, all the deltas and all, and what is the meaning of the delta. And similarly, then I will compare gamma with delta and then kappa with delta and so on. And our discussion will move forward. So see you in the next part. Thank you for watching this video.